All right, today we're talking about a real unsung hero of the factory floor. It's a machine designed to keep people safe and the air clean. But here's the thing, it has a pretty dangerous secret. Yeah, it can literally explode. So, what if the solution was actually part of the problem? It's this wild paradox, right? We build these super complex systems to fix things, but sometimes the fix itself creates a brand new, totally unexpected danger. And believe me, this is one of those stories. And I'm not exaggerating here. The very same machine that's supposed to protect people can, if things go wrong, basically become a bomb. So, how on earth does a safety feature turn into such a huge flaw? Well, let's get into it. Okay, so to really get the risk here, we have to meet the machine itself. It's called a baghouse. Think about it. In so many industries, from woodworking to making metal parts, the air gets filled with all this fine, hazardous dust. And the baghouse? That's the hero that comes in and cleans it all up. The whole idea is actually pretty simple. The best way to think of it is like a giant industrial-strength vacuum cleaner. So all that dusty air gets pulled into this big container that's just filled with these massive fabric bags. The air goes through the bags, but the dust, it gets stuck on the outside. And what comes out the other end is nice, clean air. And these things are, wow, incredibly effective. I mean, a good baghouse can capture over 99.9% of all that dust, even the teeny tiny particles you can't even see. So yeah, they're absolutely essential for keeping workers safe and protecting the environment. But the real genius, the really clever part, is that you can use them over and over again. You know that filter in your furnace at home? You just throw it out when it's dirty, right? Well, you can't exactly do that with hundreds of filter bags that are like 30 feet long. So the most important thing about a baghouse is that it can clean itself. Let's take a look at how it actually does that. The first method, the oldest one, is called a shaker clean. And it's exactly what it sounds like. There's a motor hooked up to the top of the bags. And when it's cleaning time, it just shakes them like crazy. This creates this wave that cracks that caked on dust and makes it fall down into a hopper. Super simple. But man, it's pretty rough on the bags themselves. So they needed a gentler way to do it, especially for more delicate filter materials like fiberglass. That's where the reverse air system comes in. What happens here is the main fan stops, and then clean air is blown backward through the filters. It makes the bags kind of collapse in on themselves a little bit. And just that gentle change in shape is enough for that dust cake to break off and fall away. But the one you'll see most often today is also the most dramatic. It's called the pulse jet. This thing uses a short, super powerful blast of compressed air that shoots right into the top of the filter. It creates this shock wave that rips down the bag, snapping it outward and just blasting the dust right off. It is incredibly fast, super powerful, and you can even do it while the whole system is still running. Pretty cool, right? Okay, so we've got this amazing machine, right? Keeps the air clean, a real feat of engineering. But here's the twist. All that amazing efficiency, all that collected dust, all of it stuck in one enclosed space, well, it creates a literal powder keg. There's this quote from some safety experts that just hits the nail on the head. They said, "A dust collector is a perfect environment for a dust explosion." And it's so true. The whole point of the machine is to gather all the ingredients for a disaster and put them neatly in one box. This right here is called the Dust Explosion Pentagon, and it shows you exactly why these things are so risky. See, for a really bad dust explosion, you need 5 things. A baghouse automatically gives you 4 of them. The fuel, that's all the dust it's collected. The oxygen, that's in the air it's filtering. Dispersion, well, the dust is floating all around in there. And confinement, the whole thing is a big metal box. So you've got 4 out of 5 ingredients ready to go. All you're missing is that 5th piece, an ignition source. Just one little spark. That's all it takes. So yeah, the risk is huge, but the good news is the engineering that's gone into stopping it is pretty incredible too. There's a whole field of safety science dedicated to making sure these things don't blow up and take the whole factory with them. And this protection, it's really built on 3 main ideas, or pillars. So what are these 3 pillars? They are explosion venting, explosion suppression, and explosion isolation. The easiest way to think about them is like this. One is a passive defense, one is an active defense, and one is all about containment. Each one comes at the problem from a totally different angle, and a lot of the time you'll see them used together. All right, let's break them down. First up is venting. This is the passive approach. Basically, you install a weak spot on the collector, a panel that's designed to blow out at a certain pressure.
So if an explosion starts, boom, that panel bursts, and all that force and fire gets directed safely outside. On the other hand, you have suppression. This is an active system. You have these super fast sensors that can detect an explosion the very instant it starts, and they immediately blast the whole area with a chemical that puts the fire out before it can even get big.
And that third pillar, isolation, is absolutely crucial. Now, this one doesn't stop the explosion inside the collector itself. What it does is stop it from spreading. It uses these special high-speed valves that will slam shut the moment an explosion is detected. This traps the explosion and stops it from traveling back through all the ductwork and, causing a chain reaction that could destroy the whole facility. Now, this isn't just people making their best guess. The whole science of protecting these systems is governed by really strict standards from the National Fire Protection Association. You'll hear it called the NFPA. They have these huge documents that spell out exactly how you have to design and install these life-saving systems. So there you have it. The unsung hero that cleans our air turns out to have a pretty dangerous dark side. But it's a side that we can manage with some really smart engineering. It kind of leaves you with a big question, though, doesn't it? As all our technology gets more and more complex, what other safety equipment, the stuff we trust every single day without a second thought, might be hiding its own hidden dangers?